Hey, it's Professor Dave. Let's talk about organolithium reagents.
He knows a lot about the science stuff. Professor Dave explains.
So we've talked a little bit about organometallic reagents, such as Grignard reagents. That's organometallic because it contains magnesium, magnesium being a metal. And so lithium is another metal, and so organolithium reagents, which as you might guess are ones that contain lithium, are also organometallic reagents. So let's take a look at how we prepare them and what they do. So we're going to start with some alkyl halide, right? Any three R's, it could be any kind of alkyl halide, and we're going to react with 2 lithium atoms. So we're going to use elemental lithium, and we need 2 lithium atoms for every molecule of the alkyl halide. We're going to react in some nonpolar aprotic solvent like hexanes, and we're going to get our organolithium reagent. That's our organolithium reagent, and then the lithium halide byproduct. So that is the way that we prepare them. And so all it is some carbon connected to a lithium atom. And so here are some examples of some common organolithium reagents. We can have methyl lithium. So that's a very common one. We can have n-butyl lithium, where N implies that it's a straight chain butyl. So we've got 1, 2, 3, 4 lithium. And we can also have tert-butyl lithium. So here's a lithium, and this is essentially a tert-butyl group. So these are 3 probably the most common organolithium reagents. And so what are the properties of organolithium reagents? We remember when we looked at the Grignard reagents, right, this is a bit different because we saw that the magnesium atom would insert itself into that carbon-halogen bond, whereas here the lithium simply displaces it. So we don't have that halogen anymore. We just have lithium. And as it happens, lithium is even less electronegative than magnesium. So whereas with the Grignard reagent, we saw that we had a partial minus charge on that carbon because it was a polar bond and carbon was pulling electron density away from magnesium. Here we see that effect even more so because lithium is less electronegative than magnesium. So this is an extremely polarized covalent bond. This is a very significant partial minus charge on the carbon, so much so that this behaves almost like a carbanion. It is almost as though this carbon has a formal negative charge. And of course, we know that that means that it is extremely reactive as a species. So what are some things that we can do with these organolithium reagents? One very common thing is that these are just sources of nucleophilic carbon, again, very much like Grignard reagents. So here's n-butyl lithium, and remember that this carbon attached to the lithium is the one that bears that very strong partial minus charge, almost like a formal minus charge. So this is clearly the nucleophilic carbon. So that can come up here and attack a carbonyl, just like a Grignard reagent. And now we've got, so this is the bond that was formed right here, right? We've got 1, 2, 3, 4 carbons. That's those 4 carbons. And then these 2 carbons are right there. And we've got that oxyanion. And then, of course, any kind of acidic workup, ammonium chloride, what have you, we're going to be able to protonate and we're going to get our alcohol. So this is extremely similar to Grignard reagents. We could also do that with a Grignard reagent and might want to use this instead for various reasons. But then one big difference is that we typically would not use a Grignard reagent as a base, but these organolithium reagents are excellent bases because carbanions are very, very strong bases, right? We know that alkanes are not acidic whatsoever. They do not want to lose a proton. So if by any manner you get a carbanion, it desperately wants to get that proton back to become an alkane. And so we can use organolithium reagents as bases. So one common application, we talked about how we can deprotonate terminal alkynes to get that acetylide ion to go do some SN2, do some synthetic chemistry that way. So we can use an organolithium reagent to do that, right? We might use sodamide, NaNH2-, but we also can use an organolithium reagent. So we can go ahead and get that proton on the terminal alkyne, which is going to produce the acetylide ion. So then that is going to be able to go and attack an alkyl halide, do some kind of SN2, do some more synthetic chemistry. So that is a little bit about organolithium reagents. We talked about how they are prepared, some common examples of organolithium reagents, the properties of organolithium reagents, and then 2 very common applications for organolithium reagents. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.